So now, having discussed about the ground back to ground case of the projectile motion, let us now venture ourselves into what we call the actually a top horizontal released ground case of the projectile motion. Now this is the case where the object has been released from the top of the building and horizontally up to the ground level. Now let's say this is the case. Say we have, let's say, a top of the building. Let's say this is a building, and that can be something like this. And let's say we have the object that has been released from the top of the building. Now it should be like this. Let's say this is the case. And after the object actually get landed on the ground, let's say this is the ground level. Now let's say the height of the building is given as h. Now I should have to use another key. Say the height of the building is given as h in that case. And now, assuming that the object has been released, and let's say with the initial velocity given as v in that case. So now there are some things to have to understand about the motion of the projectile motion, which is this. In other words, there are some things you have to understand about this kind of the projectile motion, in the sense that let's think of having the analysis along x-axis. Like the way we discussed about the ground back to ground case of the projectile motion, analysis will be independently done. Now, what is the initial velocity along x? Now, since the object has been horizontally released, what it does is that the initial velocity along x-axis, it is the same launch velocity. So which means the initial velocity in which the object has been released with, it is also the initial velocity along x-axis. So which means we'll have it in the same way. And on the same note, acceleration due to the gravity is 0 along x-axis. Much as the along x-axis gravitation force is not felt, so acceleration due to the gravity remains the same. Now, as the object is going to strike the ground, you will have to strike the ground with two components of the velocity. We'll have the final velocity along x, that will be given as vfx. So in this case, since the along x-axis acceleration is actually 0, what it does is that the way we discussed about the ground back to ground case of the projectile motion, vfx will be the same as the vix, and that corresponds to half it is the launch velocity. So now, which means the velocity in which the object has been released with from the top of the building, it is the same as the initial velocity, and also it will be the same as the velocity in which the object is going to strike the ground with along x-axis. What it means is this. So I know what it means is that the actually final velocity along x-axis will be the same as the launch velocity, if that's the case. So which means we'll have it as that. So that's what it means there. Now, what is the distance in which the object has to travel along x-axis? From the point of the release to where the point is going to strike the ground. So which means what we are looking for is actually this distance. We are looking for this distance. So what is that distance? And the distance itself is given as the horizontal distance. So how should we have the horizontal distance if this is the case? So now the horizontal distance is can be given as vfx or vix, and which is times time, which is the time t total. So which means the distance which means the time takes for the object along x-axis to move from the point of the release to where it is going to strike the ground. it will be the same time, it will be the time for the whole entire journey. So which means horizontal distance is the same as fx, actually vfx times time, or we can have it as vix times time, or we can have it now in this case longitude velocity times the time takes, which is the total time. So that's how the horizontal distance will be calculated in this case. So have that as the horizontal distance. So keep that in mind. So which means if we have the horizontal distance and that we have the longitude velocity, can be able to have the total time for the whole entire journey, using this formula. So keep that in mind. So that's the analysis of this case of the projectile motion, and are basically along actually x-axis. Now how about the analysis along y-axis? Now what is the initial velocity along y-axis? So initial velocity along y-axis is given as well because the object initially has been released horizontally. So this velocity has a zero component along x-axis, actually along y-axis. Hence the initial velocity along y-axis is given as zero. I understand you can remember about the vector resolution, and that's the basis of all these perspectives. So now how should we have the final velocity as the object is going to strike the ground along y-axis? So now how should we have the final velocity as the object is going to strike the ground along y-axis? Mind you, as the object is going to strike the ground, we'll also have the actual final velocity along y-axis given as vfy. So what will be the final velocity along y-axis? So just like we discussed about this in a ground back to ground case of the projectile motion. Now the final velocity along y-axis will be calculated using the acceleration formula. V is equal to at plus u, where this is the final velocity acceleration, this is the time takes, and this is the initial velocity. Now having that, you can be able to incorporate the concept behind. So which means we'll have the final velocity given as vfy, that is equal to negative g actually t total plus initial velocity, that will be given as, of course, viy. And of course this is L, then you'll be able to have the final velocity along y-axis as the object is going to strike the ground. So keep that in mind. Of course the actual velocity will be given as the negative because the object is pointing the downwards, that is along y-axis. Hence we'll have the final velocity along y-axis being given as the negative. So now which means this is also the same as the d total. So the time takes for the object to move from here up to the landing point, it is the same time for the object to move from here up to this point along x-axis. So that one d total is the same as the d total that has been used in the horizontal distance. So you have that understood. So how can we have the magnitude, or in other words, how can we have the landing speed in which the object will have as it will strike the ground? So which means we'll have it as a speed is equal, now we'll have the magnitude of the two components of the actual final velocities. That will be given as vfx square plus vfy square. You have that, then you'll be able to have the magnitude of the landing speed. And afterwards you'll be able to have the actually, now the landing speed is given as this. So have that understand. So this is the landing speed, that will be the magnitude of the two components of the vectors. And the direction is given as this angle theta, that will be given as the tan inverse of, now should be theta is equal to the tan inverse of now vfy divided by vfx. So you have that understand. So that's how we analyze actually that case of the actually projectile motion in that order. So apart from, so how can you be able to find the height of the building? How can you be able to have the height of the building if this is the case? So now the height of the building, which is this one, is calculated using the displacement formula that is given us. Now have it as AC is equal to UD plus, now since this is now plus half AD square. Now in the case of the free form motion, which means we have H is equal initial velocity along Y, that is given as L of course, so which means we have negative GD square, where this D is the actually a D total, which is the same as the total time. So which means we'll have that and as that. So that's how the height will be calculated in that case. Of course it will be given as the negative because we're actually, because this is a part of the displacement. Now the object moving from the top here up to the ground level, the displacement will be given as the negative. No wonder height will be given as the negative, because that is the same as the displacement in which the object has to have, as it has to move from this point up to this point in that case. So that's how the actual height will be calculated. Likewise, if we have the height of the building, we can be able to have the actual total time using this formula as well. So if we have the maximum height, then if we have the height of the building, then you can be able to have the total time using the same formula as well. Of course, as you'll be substituting the height, we'll have it as the negative, because that's the typical displacement. So we'll have it as the negative, and such that with this negative, the time should be given as the positive. So take note of that. So which means there are three actual ways in which the total time is being used. We are using the total time in the horizontal distance formula. We are also using the total time in the formula that is used to have the final velocity along y-axis. And likewise, the height of the building can also be calculated using this other formula. Displacement is equal to U plus V over 2 times T, where this is T total initial velocity along Y. This is the final velocity as the object is going to strike the ground. So this is the maximum height we're talking about, which is the height of the building. So take note of that. So next I'm going to see on how I can be able to apply the analysis of this kind of the projectile motion. Now some different problems associated with this kind of the projectile motion. Thank you.